ठीक है, वो तो फिगर करते हो। सेंड मी दिस प्लेस का फोटो वगैरह देखते हैं हम भी। मैं भी देखता हूँ। और हाँ
एक्चुअली वहाँ पे गाड़ी का नया खुला है वो जो था ना मार्केट बीच रिसोर्ट
हाँ
दैट हैज बीन टेकन ओवर बाय द फाइंडर ब्रांड
अच्छा हाँ
नॉट मैरिड बट some Radisson type of a brand
हाँ
but it's a very expensive 12,000 a night
मैंड्रिन वाले का
वो हाँ मैंड्रिन वाले का
दैट इज 12,000 तो क्रिमिनल। फिर मैं जो बैंकॉक चले गया।
एग्जैक्टली तो गोवा का वो पॉइंट ही रह गया ना फिर
हाँ
तो
ठीक है, देखते हैं वो तो विल फिगर। पहले डेट्स डिसाइड कर लेते हैं। होटल्स
it is going to be after 15th only you tell me you want to leave after 18th compulsorily
हाँ
मैं लेकिन after 18th
हाँ थोड़ा सा मेरे लिए इजी हो जाएगा।
so we will see 18th 19th whatever whichever Friday comes first ऐसा
हाँ
कुछ निकलते हैं
खुशबू का एंड मंथ में कहीं और प्लान है।
ठीक है
ओके
चलो हाँ ठीक है
वैसे अभी टेंटेटिव वो रखते हैं मैं लिंक भेजता हूँ
हाँ
ग्रुप पे एक बार देख लो कि कुछ रहेगा तो भेज
ठीक है
ठीक है
ओके
चलो बाय
Chris, do you have power bank by any chance? I'll just keep it on, leave it.
कितना
हो
चार्ज
गया,
है
it's set. Live streaming is set. So
कितना चार्ज है उसमें?
कितना चार्ज है इसमें? 18%. It will die.
क्या बात कर रहा है तू? ऐसे कैसे कर सकता है प्रियांक? और तू तब से चुप कैसे बैठा था?
ठीक है ना, पावर बैंक आई जस्ट, ये कॉल चल रहा था।
पेशेंस
पेशेंस की बात नहीं है।
Yeah. Good evening, everyone.
और तेरे को अगर कॉल
नहीं, इट्स फाइन, म्यूट पे हो।
अगर तेरे को कुछ कॉल है तेरे पास सीपन?
सीपिन है मेरे पास, हाँ
C2C है ना?
हाँ, C2C है।
Hi, man. How are you doing?
हम जो गए थे वो एक्वा था।
क्या है?
एक्वा
Which festival?
वो तो बहुत अच्छा था ना।
चले?
Hi, madam. Can you hear me?
हाँ, I'll join in
Yes. Okay.
2-3 minutes.
हाँ?
I'll join 2-3
Okay.
minutes.
तो
So we'll start in 1 minute.
हाँ हाँ,
ये मेरा बैग लेकर आना, ठीक है?
ओके, डन
इसमें चाबी है।
डन डन।
So, dear participants, that's a pre-test. That is, you can fill that forms. After the sessions, we'll ask the same set of questions just for that certification. Okay. For that certification. So you know that Maulana Azad Medical College, Maulana Azad Medical College Innovation Center. So today's speaker is someone I genuinely admire him. So in fact, that the first time I heard that AI word from him, so decade ago. So it's a big inspiration in my journey AI as well. So Sanatan is a highly experienced data scientist, leader who works for the intersection of biology and technology. He is currently a head of the data science at Inveni AI, where he leads the development of Alpha Meld platform and also has advised AI system to help to speed up the drug discovery and healthcare innovation. So he has more than 17 years of experience in the pharma as well as biotech world. So over the years, he's guided many companies on how to use that AI and machine learning, led cross-functional teams, and also has so much of solutions that has a truly impact on healthcare. So his experience it covers the predicting modeling and also AI ML in drug discovery. So and also advanced analytics. So one of that drug is already FDA approved. So that was using that AI and also NLP. Okay, this is definitely a huge milestone. So usually it will take around 10 years for normal process. It was done in within 5 years. So more than all these achievements, he has bring the big deep passion for that improving the healthcare using data, meaningful and collaboration way. So please join me in welcoming Sanatan, a mentor, visionary, and also someone who continues to inspire many of us in the field of AI. So welcome you, Sanatan. So during this, so I will stop sharing and you can continue sharing. So what we'll do is that, I will ask some questions. Okay, we are very new to that NLP, and also many of us we don't know what is NLP also. So during the process, I will ask some questions. You can answer. You can explain that to us. So in between, during that participants, you have anyone come up with the questions. So we will. I will keep on asking that clarification and explanations. Okay, if I didn't get that, is it okay? Yeah. Yeah. Thank you. Okay. The first, before that, most of us we came to that. Most of us familiar with AI because of after that the introduction of the ChatGPT into the public. So before that, we don't know much about that AI. So because of I worked with you, and also that because of the BioExcel that I come across. Other than that, it was a new term. So even that many of us we don't know exactly what is NLP. So and also how that NLP is different from the ChatGPT. It may be that Gemini, that various large language model is there. So and also it is how that kind of this what kind of LK data fit to this NLP.
Right. So, and in a nutshell, we are trying to process the natural text that is written by, in our specific use case, it's written by either authors in scientific literature or medical doctors writing prescriptions or defining patient outcomes, and also clinical trials outcome and clinical trial designs. So, uh, most the process of natural language processing is essentially transforming the unstructured data into a structured data format. This is the key. Um, so when you read a specific article, if I take an analogy of an article, um, and let's only take a small section, let's only take title and abstract. So people are trying to describe, or the authors are trying to describe what they have done and what are the conclusions essentially for the specific article. Now, through natural language processing, we can extract only the content of it rather than reading the full title abstract and trying to consume it as a go. We can extract that what genes are mentioned, what diseases are mentioned, what therapeutic interventions are there, and what are the relationship between them. So we can just extract the knowledge graph from that article and use it at a scale rather than using one article at a time. Um, yeah. So another use case could be a patient diagnosis done by a doctor. So what were the observations? What were the symptoms? So we can directly connect a written text to into patient ID. What symptoms do they presented, and what was the diagnosis? And then simultaneously, we can also connect that what drugs were given. So all of this can be extracted in a in a scaled version, and then consumed at will.
That is what do you mean by that language? There is a various term like large language model.
Large language model, exactly. So, so this is in a nutshell what natural language processing does. Now, in order to achieve natural language processing, there are various ways. Um, One of the way is called BERT, BERT, which is it's a language transformer model which came before large language models. It was an earlier version, but it has a higher statistical significance compared to large language models. So it's predictable, and it can be used at scale with a very clear outcome. For example, if you want to extract all the drugs from patients' notes, you can train this model to identify how drugs are written and then extract them at scale. So these are called named entity recognition methods. Then we have a relationship extraction. So if there are, so we have symptoms, disease, and drugs, and we can extract what are the relationship between them if that is mentioned in the text. Um, these are called BERT models. The large language models are not that predictable. They are not consistent in terms of the outcome. So for the same, you can fine tune a model to return these named entities as well as relationships, but it will again be a text outcome. It can be in bullet forms. It can be in in a structured format as well. So these days, or like for quite some time, we have these models that are actually using JSON output. So essentially, what it means is that you will get a structured outcome that can be directly stored in the database. So that is something that we can do. A, but again, I'm coming to the inconsistency. So I mean, today you ask these large language model that yes, we want to extract drug diseases and symptoms, and it will give you a list. But tomorrow it might miss out something because it's not consistently trained to extract that specific thing. It may not, but there is a high chances that every time it might give something else.
Okay. Yeah. So next comes that there is so much of applications of that NLP in various sector. It may be business, it may be finance. So what is applications in that healthcare sector, especially the clinical applications? So how that hospitals can be used. So clinical workflow, and also that how that clinical decision making support system it will help enhance that system.
Right. So in terms of um, in terms of clinical workflows, let's take very specific examples. So we can take example of hospital settings, or we can take example running a specific clinical trial. So in both of these cases, there are various notes that are generated on an ongoing basis from doctors about patients. And these patients' note can be automatically converted into usable data that can be used to generate insights at scale. These days, there is usually a mix of things. Especially in US and EU, there are already these type of models that are continuously being used. So we can extract. So if a clinical trial is ongoing, there are different time points at which the data is collected in terms of side effects. What are the primary outcomes? What are the secondary outcomes? What were the measurements? So all of this data, if it is recorded in an unstructured way in patient notes and everything, so those can be transformed directly into either Excel sheets or directly into the database so that those can be consumed uh, at scale. So this is one particular example. Yeah.
Like that. So it is a structure that most of the Western European US they're following that EHR system.
Right,
So in
exactly.
India, it's a most of the paper and pen prescription format. So is it possible to convert that paper and pen that what are the
Yes.
prescription
So very recently there was this new DeepSeek large language model that was trained based on optical character recognition. So you can directly give it an image, and even like the other models also, they can easily extract what is exactly written in the image. So even if they are handwritten notes, these can be transformed into regular text directly. And it depends. I mean, like how one of the key thing is the um, how easily even humans can recognize those handwriting. So those are that is something that I think is a challenge. But I think if for consistency's sake, we might need to fine tune a specific model to do optical character recognition in a better way. So we might need to train on the specific notes of doctors and if the handwriting is difficult to recognize. Otherwise, I think regular English writing is very easy to recognize. Yeah.
And also in between some questions over there. Like, yeah, we will come to the drug discovery part. So once we'll finish about that clinical applications. So in clinical applications, such a clinical decision support system, like example, if it is a patient is in ICU, suddenly the various parameters are there.
Right.
So that various parameters is included into the EHR. So and also predicting the NLP plus AI. So how that it can we predict that early using that?
Yes, so those are different type of machine learning models that we can actually use. So in one of the use case, what we did was we were working with a university, and the aim was essentially to predict that how much dialysis, when patients are coming for dialysis, when they have kidney issues, that how much blood need to be cleaned up, and that number needs to be extrapolated. So essentially what we need to do is that then use the patient data to train the model that when these type of parameters are there, this is the volume that needs to be cleaned using dialysis process. If you go higher, then there are chances that you might get some sort of post dialysis complications, and but these are traditional machine learning models which can be used where you can use patient data in terms of their race, ethnicity, their age, sex, what kind of background do they have in terms of disease, and use all of these things to train a machine learning model to predict that what kind of volume you might get. So these are traditional regression models that can be trained, or a deep neural network can be trained in terms of loss value understanding. So these things can be trained to predict those things as well. Yeah.
Yeah, so first we covered that out what is NLP, and also use a huge data set and how it can be useful for that applying. So EHR, using EHR plus NLP plus AIL, how can we come to that prediction of clinical?
Recording in progress.
Can be done. So like prescription. There is one question about before going to the next level.
Yeah.
So there is one question from Mridula, Dr. Mridula. What are the method used to train NLP? What factors affect the accuracy and quality?
Okay, so I will give an example of drug discovery over here. So the first step of this process is defining what are your entities and relationships. So entities in drug discovery, we went for genes, drugs, disease symptoms, cells, tissue, organ, medical devices, and so on and so forth. So these are the entities that we need to clearly define. And then for each of these entities, we also need to have ontologies. Ontology essentially means that we need to have the name, recognized name, and also synonyms mapped to those specific entities. Once we have these two combination, then we have to manually train on. So we went to almost 50,000 sentences in order to get an accuracy of somewhere between 98%. To recognize 10 different type of entities. And there are tools where we can load the sentences, and researchers and scientists can go and just drag and label one entity at a time. And then once these labels are done, then we can train a model and see that what is the accuracy associated with the model in terms of correctly recognizing a specific there are some out-of-the-box model already on Hugging Face. So Hugging Face is a repository where models are available free of charge. Those can be directly used. But for custom use cases, it's always good to train based on your specific data and sentences that you are trying to
So
extract.
what we generate.
Yeah.
So according to what our data, if we use the train, that will give.
Yes.
Okay.
Yes.
So and also one more question, like, yeah.
So
like would NLP put that medical transcriptionist out of work? So whether it will take care of that all the transcription work.
So what I'm trying to so these large language models and AI tools, these are not removing the human use directly. They're just making us more efficient. For example, in a non-healthcare scenario, I mean, a customer care agent who has to send emails to multiple people on a daily basis for, say, suppose if we take a credit card thing, so you have to send several emails, customize emails, and so on and so forth. Or if customer is asking something, you have to continuously respond to those things. Now, responding to those emails are becoming faster because you can directly use AI, type 1 and 2 line, and it will create a full email for you. Now, the same person is able to do 3 or 4 times more work. So now you don't need a team of 10 people, only 2 people can do all the job. So the same thing will happen with medical transcription as well. So a small number of people can do job of more number of people because of the AI and these improvements. Yeah.
Yeah. So many questions about drug discovery. So before drug discovery, like example, in India, there's so much of various languages are there. So we know that it is like English, it will recognize because of so much of data is there that ChatGPT works very well. So because of that various reasons, the doctor communication with Hindi, Tamil, Kannada, so various languages. So even that is a one government of India that Bhashini is there. It's easily convert that various local language into English. Then it can be that NLP use and also whatever the output we want to. So can we develop that accurate model? Is it possible to that local language also like English?
Most of the literature and data is mostly available in English throughout the world. So it's a universal language. So any other language will never reach the level of English. It can reach to a decent level, but there is definitely things lost in translation always, in my opinion. So we need to cross-check and verify that things are actually transcribed properly. And the other problem with speaking other languages is the dialect and some specific words which are not clear to a lot of people. Like I come from Rajasthan, and my town was essentially very near to Haryana border. So it's a mix of Rajasthani and Haryanvi language together that is continuously being talked. And that is not usually recognized by people in Jodhpur, say suppose. So that is something that is very subject specific, but I think Hindi would be a very good language because there is already a lot of data on Hindi, and it can be a very good translation. But other languages I'm not aware of because I don't speak those languages, so it would be difficult for me to say. Yeah.
Like even humans, we can't able to understand that. Even the AI also similarly that based on the trained data. Does NLP helps in semantic interoperability too, or is it a completely different concept?
Semantic interpretability is there is always problem with semantics, how or what person is trying to do. So I have my college colleague who's currently assistant professor in University of Pennsylvania, and some of the examples that he saw in US was the doctor's notes are usually in not sometimes not in English, like a medical dictionary kind of thing. They would probably say that like this won't bite, a colloquial kind of thing or phrasing, which essentially so for those kind of thing, you need to then train the model accordingly to understand the semantics of what exactly is being talked about. So if you are that's again a use case basis. Sometimes it's works, sometimes it doesn't work. It's yeah.
Okay. So next section we will go to that research and innovation. Like how can NLP accelerate the literature, the mining and systemic reviews? So how that so much of PubMed that every day that 10,000 of publications is that happens. So we can't up to date each and everything. And also we want some concept. Is it possible? And also what role does NLP play in? Okay, we will come to the discuss next part. First, the literature mining and systemic review.
So literature mining, so we have developed a tool, AlphaMelt, where we extract all scientific literature, title, abstract, and wherever full text is available for literature mining by authors. And we continuously process and extract relationships and entities from there. And every other day, I see a new relationship. There's the first time two genes are mentioned together. There is the first time a gene and or a protein in a disease is mentioned first time. And then there is, so these are new relationships, and then there is relationships that are getting strengthened, like the same relationship mentioned twice, thrice, or even more by different authors. So that's just creating a base where we can have a knowledge graph where all of these relations are continuously captured. And these models need to be trained at least 6 months to on a yearly basis to see that whether there are inefficiencies associated to it. Once we extract these models, these relationships and entities, then we can build on top of it. We can see that what authors are saying right now versus what they used to say 10 years ago. Is there a difference? Or previous understanding was that gene A activates gene B, but now people have created much better evidence, and now it's not activation; it's actually inhibition. So those type of things can be tracked on a regular basis, and while generating hypothesis or creating novel targets or drug repurposing concepts, these things are super helpful because not only we can just read the list of all the, so you, if you have everything already, then you can just type in the name of the disease and you will get a list of genes that are most commonly mentioned with them with the specific type of relationship. So whether the drug causes the disease or whether it treats the disease, and what is the evidence and how many research articles are saying that this is the relationship. These are direct evidences. The indirect evidence would be that drug activates another gene or protein, and then that gene's activation or inhibition is causing or treating the disease. And these are individually mentioned in different articles. There is no article where the drug is connected to the disease. But this way, we can actually use intermediates. And intermediate, I'm mentioning a protein right now, but it could be a cell, it could be a metabolite, it could be any of those entities that can connect A to C. Yeah.
Now, for example, you are that various startups and various companies are doing as a faculty in medical college. So how can they utilize that NLP in having literature mining, their article write something, or research projects,
Research
even
projects, right?
students or else postgraduate
So,
students as a faculty.
yeah. So these large language models are quite good, but the problem with large language models is that they are not comprehensive. Like if I want to know that what all proteins are associated with a specific disease, the large language model will only give me 10, 15, 20 most commonly things, gene or proteins that are mentioned with that particular disease. Uh, However, the data is much, much bigger than that. And then those genes and proteins are also interacting with each other to create hubs and pathways. So those things are very, very important, and those things are missed by large language model because they can't. The context size is not that great. So I think, in my opinion, it would be good to spend some time and create the knowledge graph.
Okay. So, like example, if you ask any question to Perplexity or else ChatGPT, it will give some give a drug related to gene something. It will list. So you are saying that it is not comprehensive. So we
It will
need
never
to
be,
work.
yes, exactly. It will never be comprehensive, in my opinion. Because, let me give you an example for this. Let me share my screen.
So we need to create a knowledge graph. What is knowledge graph and how we can do that?
So, before knowledge graph, let me give you an example. So, you can see my screen.
Yeah. Yes.
So this is a specific project that we did where we were trying to identify what all obesity targets are associated to um, uh, could be used as a potential target other than GLP-1 that is ruling the market right now. We started with all the genes. We saw that which all genes are associated with it. So we were able to narrow down to 5,000 targets. An LLM will never be able to give you those 5,000. Then we were trying to see if we are going to do some docking studies, we want to make sure that the 3D structure is available. So out of these, how many has 3D structure available? Then out of these, how many has low risk level? There is a proof of concept there, either preclinical or clinical, direct or indirect. Um, then are there off target effects or safety concerns associated? And then finally, is there a way we can understand that there is an impact on clinical trial endpoints? So by doing this, you can reach from 9,000 to 132 potential targets, which also include GLP-1 and the top targets that are already being studied. So even like getting to this 132, a large language model will not be able to give us all of this data. So this is like a sample knowledge graph that we built initially, which has so many different type of relationships and hubs that are associated to each other.
For example, it's everything is done based on the whatever the literature is available, searching that, selecting the data from that.
Exactly.
So it's not possible to read and collect the data and everything. It will take a huge amount of time and manpower.
Exactly.
So can we use as a fact without access to that, your access to that language model, that knowledge graph, as a researcher independently, is it possible to develop use this kind of
It would be difficult, I would say. But I think you can use Open Targets. Open Targets is a website where all of this, at least not in this granularity, but there is a decent amount of data between gene to gene relationship, gene to disease relationships that can be used. And I think it's a very good starting point because just building this knowledge graph and maintaining it is a huge task.
Yeah, it's so the data, so much of data is required, memory power. So and also next question is that what role that NLP play in drug discovery? You already told. So in also can you elaborate a little bit about the drug discovery and also trial design, pharmacovigilance?
Right. So pharmacovigilance. is another place where we don't need fine-tuned machine learning models. We can directly use large language models in pharmacovigilance. Because essentially what we want to do is we want to continuously monitor, say suppose we are doing pharmacovigilance on semaglutide. Now for semaglutide, what all articles are getting published? That will not be a huge list, and we can continuously monitor them by various sites. And then use those articles where patients are actually tested and specific endpoints are being tested or some side effects are being tested, and we can continuously monitor them and extract. So this would require agentic analysis where you, on a daily basis you see that for semaglutide are there new articles, then use various prompts to extract very specific information from these literature, and then organize them in a way that can be consumed by us in a pharmacovigilance study. So this is something that can be automated, and it depends. So one is that which is an open-ended thing. So we look for everything wherever semaglutide is mentioned. Another way is that we want to keep a track of things that these large language models are very specific. If you give them very specific tasks, they do a pretty good job. So you want to look for if there are muscle loss related articles that are published with semaglutide. So you just want to extract that information if there is somewhere mentioned in those articles and focus only on those points. But if you ask that I want to know everything that is there in that article, the LLM will miss out of something. So identifying these things one by one, breaking down these things exactly as a human do, that is the best case for using a large language model. Yeah.
For example, Avi, at present, that one filling the form vigilance form, it takes so much of time. That enter into the EHR, that system, so that collecting the data. So rather than if it is EHR is there, automatically if a patient developed any ADR side effects, automatically it will capture and it will store. It will
exactly.
Even it may be that any devices, transplant materials, if it is there in the patients, so using that NLP can be extract that side effect, right?
Okay. Yeah, exactly. Because here the scope is small and we don't want to have everything at our place, but rather use something that we use on a regular basis, like large language models. They can be optimized to do this.
There is another one question. So, what are the challenges in developing a reliable NLP system? How these problems are addressed at present? I don't think that we, as a researcher, we can't develop that NLP model as such.
Right.
We need to use that already developed model.
Exactly. So that's the biggest problem, that these knowledge graphs are very hard to maintain and continuously update. And more often than not, the open source models or knowledge graphs that are available do not directly fit in the use case that you are trying to develop. So there is always something that is lacking. So that I think case is something that is always there when we are trying to use open source models or graph databases.
And also there is one more question is like each hospital maintains their different EHR system. So like there is a one Snowmade city, so that mine that terminology for that whole medical they follow that.
Dictionary.
Yeah. So is it possible?
Yeah. So we so we use it primarily for ontologies, not for relationships or the knowledge graph kind of thing. It's good for at least what we did last time, because our use case was very specific. We wanted to see a very clear relationship mentioned between proteins and diseases and symptoms. And we wanted very clear relationships that we have defined. that would ease the or accelerate the drug discovery process.
For example, even Ayushman Bharat Digital Health Mission, they have created the app, and also they plan to give that each patient, each doctor one unique ID. So any patients of India, they can upload that data, whatever their healthcare, EOPD, slips and everything into that. So it will be maintained, security and safe. So like he went to the one hospital, he will upload. Another hospital, he will upload. But the terms, each one is different. So so that combined together,
Yes. I think so we don't have problems with drugs. There is very systematic way of writing things. There is no problems with proteins. There is no problems with cells. Disease has huge issue. The problem, the reason why disease has so many issues, or the disease terminology has so many issues, is that disease is not an entity. Disease is essentially a group of things that is very loosely defined. I mean, on paper, you can say that a person has diabetes type 2, right? But even diabetes type 2 is not always alone. It's always with something else as well.
Yeah. So and also each doctor will write the different type 2 diabetes,
Type 2
TM,
diabetes.
or else diabetes.
Exactly. So these type of things, so synonyms still can be mapped back. But the problem in a nutshell is that although ICD-10, 11 codes are very helpful in using this, so I think doctors need to start using ICD codes in order to map things properly, or have multiple ICD codes connected when there are multiple symptoms associated. I think rigidly making sure that we are following WHO guidelines is essential for disease standardization.
Okay. So come to the last section, like education and future outlook. So how that NLP reshaping medical education and training? So what is the next multimodal models, clinical agents, and also agentic AIs are there?
So
Medical education and training is most.
I think there is a huge scope of using these large language models or agentic AI or agent orchestration in a way that can simulate a whole pipeline process. In terms of education, I think it will. I haven't really thought about it that much because again, I'm way off education these days. So
like for example, that every medical student, wherever I go, everyone uses the ChatGPT. So
Yes.
even nursing, physiotherapy, BDS. Yesterday I went to that BSc physics and chemistry. Everyone. So there is 100%.
Yeah.
So for their education purpose, that even that whatever if they want to read nowadays, they are not referring any textbooks. So they're asking ChatGPT, they're collecting that information ChatGPT.
Right.
So what's your thoughts on that? Can be reliable or else?
I think that these models are quite reliable. The problem happens when there are complicated questions asked, or the questions that are in multiple fold. So one of the things that I generally recommend is that when you have a bigger complex question, rather than asking ChatGPT directly, ask ChatGPT to convert this big question into um, small questions essentially, and then ask them one by one to it, and then ask it to essentially summarize everything. That way, I think you can get much better answer or better knowledge. And also, one of the thing that I've seen is that you should always mention to these large language model is that do not um, increase the text size limit. So usually, I mean, even if you ask a small question, it will give you a huge essay on it, which doesn't really help in terms of reading. So it's always good to ask it in the beginning that give me short answer or with bullet points or something like that, so that you have very And it depends what kind of questions you are asking. If you are asking very specific questions about physiology, biology, clinical trials, it would probably give you a right answer, but it might also give you outdated answer as well. So checking the references is very important.
Okay.
Yeah.
Another one, Runit is asking questions. What are the other example of NLP apart from LLM? Any other?
So I told BERT is the other example, which was the precursor of LLM, and those are still used because they are more reliable in terms of consistent outcome. Whereas these large language models are not consistent. They like today you ask a question, they will reply something. Tomorrow it will reply in a different way altogether. Yeah.
And also, how to authenticate the data that have been used to train the NLP? I think we need to collect the data, authenticate.
So again, NLP training, we have to then understand that what we are doing. Either we are training BERT or either we are fine tuning the large language model. So if you are doing BERT, and actually both of them, you have to provide manually trained data or manually classified data. In terms of BERT, we have to label that what are the relationships and entities in a specific sentence or a specific paragraph. In terms of large language model, we have to give it a problem statement and then tell it what it should respond. So these are essentially question answers with some context. You have to continuously build these things and then fine tune the model and then test it. So, yeah.
Like that is one clinically important, the clinical agents. So when the patients, the doctors give their phone numbers to the patients are keep on asking that various questions to the doctors.
Right.
So that if it is based on the doctor's knowledge, he has a put of that resources, and also is it possible to automate that? As a result, answers will be answered and verified by the doctors. Like example,
I think there is an ethical concern here, in my opinion, because these AI agents are hard coded not to give prescription. You can still get some small things, but it will try not to do it. So
no, not exactly the prescription. Like after follow-up questions, can I eat this? Can I eat? How much I need to? So what measurements? Right. So there's so much questions will get the doctors. So that the data, like whatever that doctor can verify that full data information. Is it possible that text in converted into that patient's whatever the test question is asked?
So I think in that case it is doable, but again we need to integrate the hardware part here, where there is a recording device or something. So you can give doctor headphones or something, and essentially there is message playback, and they can just respond yes, no, or something, and that is directly transponded. So writing things is a huge waste of time, and now that we have
no, it's automatic. We're using NLP, any extract that various particular text, something like that.
I don't think. I mean, if the verification is needed by doctor, then it's a physical verification. Otherwise, I mean, there is always chance that it will give wrong information. And the problem with medical system is that there needs to be somebody always responsible for suggestions. If we are building it for patients,
Okay. Thank you, Sanatan. There is a last question. Can different NLP model combined in the future to get more reliable information? So various models can be combined together to get it.
It's already happening. So this is called agentic or agent orchestration, where there are multiple agents collecting different information, and then there can be another agent which verifies the outcome of all of those. So these type of things can be done, but again, there is still, I think the accuracy is not the problem here. I think the bigger problem is the responsibility of that answer if we are considering patients.
Okay. Thank you, Sadan. From last 50 minutes, you answered so many questions. We got so much enlightenment. Any questions from any audience? We can take one or two more. Yeah. Oh,
Okay.
yeah. Yeah. Most of the questions we answered. Every question is answered. Okay. Thank you once again. Thank you.
No problem. No problem. Pleasure to be here, man.
So there is a after that there is a post. So we have a post test questions. Please kindly fill this post test questions as well. And also there is one question. No, is it possible to add emotion into the future responses? It's a totally different, I think.
Yeah, I mean, from the psychology perspective, yes, there are already. I've seen several tech in the conference that I was for last 3 days. There are several techs where people are using psychologist alternative in these agents and conversational agents.
Okay.
Again, but these are not real emotions. These are, again, simulated emotions that how to respond in different cases.
Okay. Okay. Thank you. Thank you once again. So that is one more that participants. There is a MIC that is organizing that MedX. That is an MedTechX. So that is on December 5th, 6th, and 7th. So is involvement of the medicine as well as a technology together. There is a workshop as well as conference. So, Priyansh,
Yes.
yeah, yeah, thank you. So we will showcase that our brochure. So if anyone interested, you can register by November 15th. So early bird registration is available. Yes, I will share that link. So there is a parallelly, there is a 3 workshops as well as conference. Okay, thank you once again, everyone.